Hi, everyone. I welcome you all to this session on analysis and design of structures using STAAD Pro software. The next 30 minutes, we'll be going through this agenda one by one. Okay. Before actually entering into the introduction and how abouts of STAAD Pro, let me first touch upon the basics, the evolution, and how computer-aided design has helped us in many ways. Basically, as a civil engineer, we have to deal with three important factors or features, I would say. The first one being, as a civil engineer, we are concerned with the design, construction, and management of constructed facilities. Here, when I say constructed facilities, it might be a structural element, it might be a substructure like foundation systems, it might be transportation systems, environmental systems, and all other such systems which are included and considered in design of any buildings. Next comes the constraints or the limitations in the form of geography. This can be seen in two ways. One is, say for example, if a building is located in India, then the codes and specifications might vary based upon the Indian standard codes. If we are going to design a building in some other part of the world, each area, each geography, depending upon the soil stratum, they have their own codes and specifications. For example, if there is one apartment block with 5 to 6 apartment buildings in the same premises, do you think this building design for one block can be copied and pasted to another? Definitely not. When it comes to civil engineering, each building is unique. There is no breadboard models, there is no prototypes when it comes to design. Each building has to be designed and considered separately. So this geographic limitations will have to be considered based upon the location, the specifications, and the codal standards. Next, the important future comes in the form of tendering bids. So now, say for example, we have considered all the constraints. We have done wide variety of calculations and we are presenting that in the form of a document or drawing to the client. And we can't get the project as such. The project will be evaluated based upon the estimation we are giving them. If we over-design the building, it might lead to a very huge cost. If we underdesign the building, the safety and serviceability might be in jeopardy. So we have to consider the structural elements, the apt structural elements going into that particular building. We have to consider the geography, the soil stratum, and also we have to be economic. Only economic tender will give us the project. So all these wide variety of diverse natures or calculations we have to consider while designing any building. Coming to the evolution of design. Initially, before the invent of all these softwares and programs, the building is designed in such a way that specialist here, I mean a specific architecture people, a civil person, a mechanical person, they will be preparing two-dimensional drawings. These drawings they'll be preparing based on their own requirements. Each drawings represent that particular element only. Once the drawings has been done and dusted, these drawings are usually made on a tracing paper. So these tracing papers are placed one above the other so that the individual one above the other in the sense the architecture drawing, above it the structure, the mechanical, HVAC, electrical, and so on, in such a way that we have to check the compatibility because each system have their own requirements, their own specifications. So we have to check manually whether the systems are compatible with each other, if there is any conflicts between these elements. So this is, of course, a cumbersome task. So the introduction of computer-aided drafting systems modernize the process in such a way that, in AutoCAD, we have separate layers. You can define separate layers. For example, there is one layer for architecture, one layer for civil, and one layer for electrical. While working on civil drawings, you can put off the other two layers. And similarly, while working on architecture drawings, you can put off the rest of the layers. So that end of the day, you can put on all the layers together. You can check whether the layers are compatible with each other. Though this made the process easier, it was still not successful. Why I'm saying not successful? Because, for example, we all know that building design is a repetitive process. It is a process wherein changes come in any time. If I made a change or make in the plan of a drawing, it has to be reflected in the section. It has to be reflected in the elevation. All this has to be done manually. So each and every time when a change request come, you have to change the plan, repeat it. There is always a chance of incurring errors. So then came the computer-aided engineering programs. These programs made it further easier because it helps us to efficiently carry out this. Now, the recent advancement, I would say, is to incorporate all the systems in one drawing. which is building information modeling system. This is actually, BIM actually acts as, come to know what is the architectural purpose, what is the structural specifications. You'll know where comes the electrical system, where comes the plumbing opening, all details. You'll know the specific material specifications, which in where. You'll know the structural element, what is the size of the structural element, what is the materials, what is the reinforcement, everything all in one place. So this, I would say, the evolution of design methodology, right from the tracing paper to the modern building information modeling system, helps us to efficiently design a building. As discussed earlier, as an engineer, our problems are diverse in nature. We will have to go through complex calculations, right? From the design of the building till the execution. We have many constraints which we saw earlier, like the soil stratum, the tendering process, and the types of elements. How this software helps us. For example, if we are designing a tall structure, what do you think the governing load case? When it comes to tall structure, the governing load case is wind. So there is pipe is created. It is placed in a tunnel structure and the wind loads are applied over the prototype model. And then there is this results and this load case in combination is used in the analysis of the building. For example, there is one huge structure which is coming under the earthquake prone area. Now we have to consider the earthquake loads along with the wind loads. So the load combinations will be both wind load and seismic load. I would say that doing a manual calculation of a building or however big it is, I won't say it is impossible. It is possible, yes, but it incurs a lot of time. It incurs a lot of calculations to be considered, and it is very cumbersome. So in such cases, in specific cases of a building, like I have mentioned here, flow diaphragm analysis, there is erection sequential analysis. When it comes to tall buildings, there is one particular we have to follow while erecting the building, which comes in the later part of the design, but still it is very important. So all this analysis can be performed efficiently and economically with the help of engineering softwares, right from the drafting phase till the execution. Since we have talked so far about the software, we'll see what are all these softwares available for civil engineers listed based upon the each phase of included in the design of a building, right from the starting. That is drafting. The initial work whenever comes when it is the design of the building is to roughly draft the architectural plan. To from the architectural plan, we'll take it over to the structure. So for this drafting, we have AutoCAD and we have SketchUp. SketchUp is mainly used to project a three-dimensional image of a building. Say, for example, I have made a rough skeleton structure. So there we need the use of SketchUp. Then comes the soil study. We have to check whether the soil stratum is good enough to carry the structure. However small, it might be a small building, it might be a G-only building, it might be a huge structure. Soil study has to be done. As an engineer, we have to go through the soil bearing capacity, the ground bearing capacity of that particular location. For this, we have geotechnical softwares like ArcGIS and EduShake. EduShake is mainly for earthquake resistant design of foundations, view of the structure, for which we have AutoCAD, Civil 3D, and Autodesk 3ds Max. Next comes the main part, I would say main part for civil engineers, which is design and analysis of a building. For design and analysis, we have many softwares. We have STAAD Pro, which is a structural analysis and design program. We have SAP, which is structural analysis program. We have ETABS, SAFE, and Revit. Revit has many elements. Revit has Revit architecture, it has Revit mechanical, which it has Revit electrical systems. And one such program which helps civil engineers is Revit structure, mainly when it comes to analysis and design of a building. So these are the few of the softwares we are going to discuss right now. And then comes the building information modeling. See, now we are going into the execution phase. You are going to the site and you want to know what is the architectural system, what is the interiors we are going to use, what is the cladding we are going to use, and we are going to see what is this, if at all there is two openings in design. You will need to know which opening is for what system, whether this is for HVAC or whether this is for plumbing. And all informations can be clubbed together in one control center, in one place, which is building information modeling. And this is gaining momentum in the current scenario, for which we have softwares like Navisworks, Works, we have Revit, and we have Tekla. Next, when it comes to execution, now say for example, everything is done. The design is done, the analysis is done, the project has been awarded. The next is we have to start the work and we have to commission The commissioning and planning of the building has to be executed in a very time restricted manner. The deadline has to be achieved, for which we have planning softwares, a software which helps us to plan and manage the execution works, the site works in a very efficient manner. And for that, we have Excel, we have MS Project, and we have Primavera. When it comes to Excel, Excel is a software which can be used for many purposes. Excel can be used even for design. Excel can be used for stress analysis also. So this is the various softwares. There are many softwares. I've listed a very few here. Okay. Now, coming to the actual software part, doesn't mean that since we have seen so many softwares right here, you can ask whether what if I go study a software and then I'll go start the designing a huge structure right immediately. It is not done in that way. The classical way of designing cannot be neglected. It is there. It has to be there. See, the growth has to be organic. You have to first perfect the skill. The skill and design of a building can be perfected only with the help of experience. Only as you grow, as you get hands-on experience, you will be able to successfully implement the experience in the form of software. For example, a small building doesn't need bigger softwares. You can do it manually. And again, this experience you can gain in the form of site. You can go and directly see what is happening in the site, which work is done first, which work is done next, where comes the conflict, how the conflict is rectified. You have to go and experience it hands on the site. And then subsequently, we have to be part of a design member team. You have to know how the design is carried out. What are the considerations they're taking into account while designing any building. So always please concentrate on your basics first. Let us understand the basics. Like basics, I mean here design of individual structural elements. There are many structural elements. We have to consider the design. We have to learn and know how individual elements are designed first, and then you go and use the software. When using the software, I always want you to know this important principle, which is GIGO principle. In simpler terms, garbage in, garbage out. Software doesn't have a mind of its own. What all you give the software as an input, it gives you back. You give it good quality input, it gives you good quality output. You wrongly suggest for example, you wrongly suggest a support condition, it will give you a wrong reaction, it will give you a wrong deflection, right? So please don't blindly follow software. If software says green, okay, the system is safe. If software says red, not okay, the system is not safe. It doesn't work that way. Concentrate on your basics. Try to manually design first to understand the concept first. Now use the form of Excel. Excel is basic designing tool. You study the design first, you implement in Excel, and then come to the software, right? Now, coming to the actual STAAD Pro. STAAD Pro is nothing but the structural analysis and design program software. Just before we saw many softwares. We saw STAAD Pro, we saw SAP, ETABS, and SAFE. What makes STAAD Pro different from other softwares? Why should we go for STAAD Pro? I would say STAAD Pro has a very good graphic user interface. It has many tools. We saw geographic constraints. For example, you're going to design a building in Europe. You have to follow the Eurocode. STAAD Pro software has Eurocode already installed in it. It has implemented many codes. It has ACI codes, it has BS codes, it has Eurocode, it has Indian Standard Code. All sort of codes are available there. You just go, you create a model, you specify which code STAAD Pro has to follow. That code can be just implemented in this program with the help of a simple click. So that simple is STAAD Pro. It has all in various design, international codes and standards implemented by default. Then comes the material. When it comes to structural element, the structural element can be a steel. It can be reinforced concrete. It can be timber also. So all these elements, all these materials are the physical properties. The physical and chemical properties of these materials has already been input in the software. So you just create an element, you create a model of an element, you select the property class. So this is the graphic user interface which helps us and which makes STAAD Pro efficient from others. This flowchart explains the process which we have to go through while designing any buildings in STAAD Pro. First, I would say to study the drawing. You will get a drawing from the architecture person or the civil design person. You study it first. You see what is there in the plan, what is there in the elevation and section. You first study the drawing, you'll understand the geometry of the building. Only then you can use the geometry, you can use the drawing in the software. Next stage is to design the skeleton structure using the software. When it comes to STAAD Pro, you can easily import the drawing from the AutoCAD. You will import an AutoCAD drawing to the software. It calculates the coordinates and it can be done easily. Or you can manually enter. You can manually specify the. You all know that the drawings are specified or done in the form of grids. That is one X grid, that is Y grids. So you specify the coordinate. The building will be, the skeleton structure can be done in the coordinate manner, either through import from AutoCAD manner or through coordinates manner. So now I have taken the drawing. I have keyed in the notes or the coordinates from the drawing. Now I have modeled the 3D framework of the structure. This 3D framework, since we are entering as coordinates, it will be in the form of nodes, nodal points. For example, a beam. You take a beam, a simple beam. A beam has two ends. So the two nodes acts as a beam element. You take a slab. A slab may have four nodes or four or more nodes. So that forms a plate element or a slab element. A column. A column again has two elements, two nodes, that is. So each and every node acts as a joint when it comes to STAAD Pro. So you key in the inputs as coordinates or as nodal points. You develop a 3D model. This is what is explained here. Nodes. Nodes becomes joints and as such different members. Then properties. Once we have specified the geometry, we have to specify what kind of structural elements goes in the building. It might be a truss element, it might be a timber element or a steel element. You have to specify the properties. We have to draw where comes the column, where comes the beam. For example, a beam runs between columns or it is simply supported sort of thing. So once we have geometry, we have given the properties, we have given the type of structural elements, then comes the support conditions. If at all it is an RC column, whether the column is simply supported, we have to specify whether it is fixed. And the same applies to beam also. If a beam runs between two columns, whether it is simply supported between the columns or whether it is fixed between these two columns or whether it's a continuous beam, all these specifications, all these constants like support conditions, we have to specify. Then comes the material specifications, whether the material is concrete or timber. So the initial step is to develop a model, to give the properties, and then to specify the support conditions. The next important thing is load cases and load combinations. When it comes to STAAD Pro, we have to individually define the load cases. For example, for a G only building, if a G only building is located in a non-earthquake prone zone area, then what loads considered is simple dead load and live load. If it is a huge structure coming under the earthquake prone area, we have to consider all the load combinations. We have to consider dead load, live load, wind load, and seismic load. When it comes to STAAD Pro, you have to define each and every load cases. You have to define separately. You have to define a dead load case, a live load case. And all these are based upon the codal standards. If at all it is an Indian standard code, we have separate codal standards for each and every load. I have stated here a separate load, the codal standards we have to follow for each and every load. So as per the lower codal provisions and as per the building load cases, we have to define the load cases and the load combinations. Once it has been done, the calculated load has to be applied on the individual structural elements. Okay, now comes the design part. I have given the geometry, I have given the material and specifications of each and every structural element. I have specified the support conditions and I have specified the load cases. What all loads is going to act on the building. I have done all this. Load cases is better. I'll insist you to design or to calculate based on an Excel sheet first and input it in the software and apply it on the element. Then comes the design and analysis. When it comes to analysis in STAAD Pro, we have many different kinds of analysis. The analysis can be a simple static analysis. It can be a dynamic analysis, it can be a p delta, or it can be some acceleration, everything, all sort of analysis. They have just, it is just like a button. You specify you click the button, it will consider for the analysis. Then we are going to run the program. We have specified everything. We have specified which codal standard STAAD has to follow, which kind of analysis it has to do for that particular building. And now I'm running the program. I'm running the analysis. Once the analysis is done, so here I've specified the nodal structure of STAAD Pro. I've specified the load calculations and the analysis, actual analysis. So we have analyzed the building. Once the analysis is done, for a support, we can extract the reactions and the displacement of the supports. To design a structural element, we can extract the shear force and bending moment. In STAAD Pro, another important feature I would highlight is the STAAD Pro will have an output file. This output file, I will always recommend you to review this output file, because after each and every analysis, STAAD Pro will give you an output file. This output file, going through the entire output file is very important, because it will help you to understand whether the analysis has been performed properly, whether there is any warning, whether there is any error in the building, in the design or the modeling of the building. And also it will help you to understand whether the structure is stable or not. So this is highly important and mandatory to understand the output file. This output file also acts as a documentation. It gives you all the details. It gives you how you have modeled the structure. It gives you details about the materials you have specified. It gives you the details about the load cases you have considered. So this acts as a documentation. In fact, it can be used to support or to back up the design you have considered. So please go through the basics. First, design it properly, analyze the output, whether there is any error or warning, rectify it. Before entering into the actual design of the building, you go through the output file completely, rectify the errors, understand the errors. Also, to understand the errors, that's what I'm insisting you to understand the basics. To understand the error, we have to know the basics. We have to understand what kind of error has caused, what kind of modeling error or design error has caused this warning. So you go through the entire output file, you check whether the information present in the output file is valuable or it is error-free. Once it is error-free, you can safely say that the building is safe and serviceable. I'll just go through the process once again. You take a drawing, you understand the geometry of the building, you input the geometry, you key in the coordinates of the building, you specify the properties, you specify the material specifications, you specify the size of the structural element, you define the load conditions, you define the support conditions, and then you define or you assign, I would say, you assign the load cases, you assign the codal provisions, and then you assign what kind of analysis has to be done by the software. You verify the results, you design, and always represent your design in the form of drawing. Whenever you do a design, whether if it might be a single beam, you might design one single beam in STAAD Pro. You might design a full building in STAAD Pro. It can be used in various ways. Even if it is one single element design, you present the design in the form of drawing. You have a support document, and then this drawing can be presented to the site, to the client, to the tendering people, whatever. Okay, so this is a general introduction, I would say, or the process involved in the design and analysis of a building using STAAD Pro. We have seen the evolution. We have seen the use of software, how the software has changed and helped us in many ways in the design and execution of the building. Now, let us see the opportunities. Say, for example, I've excelled in any software. What is going to be my opportunity in the current scenario in the field? You might be a civil engineer who is actually interested in the analysis and design of building. Because since every building is unique, you like the thrill of designing each building. You like the thrill of designing each and every element of a building. So you go through softwares, you understand the basics. As I would always insist, this again and again. You understand the basics, you understand the different elements existing in the industry, existing in the current scenario, and then you develop your knowledge on different softwares available in the market. You become a structural designer or a structural design engineer. Next case will be, I'm a civil engineer, but yet I have interest in managing things. Don't go for MBA. I'm suggesting you don't go for MBA, like common generic MBA. There are construction management institutes. There are institutes dedicatedly doing management programs for civil engineers. So now you are a civil engineer, you know the basics, but your interest is in managing a project. There are, I've stated the softwares before. You go for that particular software like MS Project, Primavera, you take a PMP course, you become a project planning engineer or a project manager. And now you're a civil engineer with interest in execution. You wanted to know what is there, what is happening there right in front of your eyes. You want to envision what is happening in the site, how a building is done. You'll get inputs from the structural design engineer, you'll get inputs from the project planner. You will become a site execution engineer in the initial phase. Further, with experience, with an organic growth, you might become a construction manager or a project manager, site execution phase. You might be a civil engineer, your basis might be a civil engineering, but based upon your interest, whether you're interested in design, whether you're interested in management or in actual execution of a building, you have wide variety of opportunities. And before gaining or obtaining this opportunity, I would always want you to understand the basics. You gain hands-on experience, you develop your knowledge on software, grow organically, and you achieve many more. With this, I'm concluding this session.